NEC Section 334.15b addresses flexible wiring methods within an enclosure. It states that flexible cords and cables shall be permitted to be installed in raceways. However, when passing through holes in covers, partitions, walls, beams, and joists, the flexible cord shall be protected by conduit, bushings, or suitable fittings that provide equivalent protection against abrasion. Applying this code section to the question of sleeving a 240-volt NM cable through 2 feet of liquid-tight conduit before the AC disconnect, the installation is permissible provided the liquid-tight conduit provides adequate protection against abrasion. The purpose of the sleeving is to protect the NM cable from physical damage. NM cable is designed for dry locations and is not intended for direct exposure to weather or physical abuse. Therefore, when NM cable needs to pass through potentially damaging areas, such as through framing members or in areas where it could be subject to impact, additional protection is required. Liquid-tight conduit, often referred to as LT, is a flexible type of conduit that is designed to be watertight and resistant to oils, chemicals, and abrasion. It is commonly used in situations where wiring needs to be protected from moisture or physical damage, especially in industrial or commercial environments. The code stipulates that when a flexible cord or cable passes through holes in structural elements like walls or joists, it must be protected against abrasion. Abrasion can occur from the cable rubbing against the edges of the hole, especially if there is movement or vibration. The conduit, bushings, or fittings serve to create a smooth, protective barrier that prevents the cable from being damaged. In this specific scenario, the 2 feet of liquid-tight conduit acts as this protective barrier. It prevents the NM cable from coming into direct contact with any potentially abrasive surfaces. As long as the liquid-tight conduit is properly secured and provides full coverage of the NM cable in the area where protection is needed, it meets the requirements of NEC Section 334.15b. The installation is therefore considered acceptable. It is important to ensure the liquid-tight conduit is properly connected to the enclosure and the AC disconnect. Proper fitting should be used to maintain the watertight integrity of the conduit system. Also, consider the fill capacity of the liquid-tight conduit. To not exceed the maximum number of conductors permitted in the conduit based on its size and the conductor sizes. Refer to the appropriate tables in the NEC for conduit fill calculations. It is also important to remember that while the NEC permits this type of installation, local codes or regulations may have additional requirements or restrictions. Always check with the local authority having jurisdiction to ensure that the proposed installation meets all applicable codes and regulations. Considerations for commercial buildings include the specific occupancy classification of the building. Type V commercial buildings are typically wood-framed structures, which may have specific requirements related to fire resistance and wiring methods. Ensure that the installation complies with all fire-stopping requirements and that the NM cable is properly supported and secured to prevent damage or strain. Selecting the correct size of liquid-tight conduit is crucial for the proper installation of NM cable. The conduit must be large enough to accommodate the cable without causing damage to the insulation. The National Electrical Code provides guidelines for conduit fill, which specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This percentage varies depending on the number of conductors and the type of conduit. When selecting liquid-tight conduit, it is important to consider the trade size, inner diameter, and outer diameter. The trade size is a nominal dimension that is used to identify the conduit, while the inner and outer diameters are the actual measurements of the conduit's bore and external surface, respectively. To determine the appropriate size of liquid-tight conduit for NM cable, consult the NEC conduit fill tables. These tables provide the maximum number of conductors of a given size that can be installed in a specific size of conduit. The tables take into account the cross-sectional area of the conductors, the conduit's inner diameter, and the type of insulation in the conductors. When using NM cable in conduit, it is important to consider the overall diameter of the cable, including the outer jacket. The conduit must be large enough to accommodate the entire cable assembly without compressing or damaging the insulation. It is also important to ensure that the conduit fittings are compatible with the type and size of conduit being used. Liquid-tight conduit fittings are typically made of metal or plastic and are designed to create a watertight seal between the conduit and the enclosure or equipment. The fittings should be properly installed and tightened to prevent moisture from entering the conduit system. In addition to selecting the correct size of liquid-tight conduit, it is also important to consider the routing and support of the conduit. The conduit should be installed in a neat and workmanlike manner, following the contours of the building and avoiding sharp bends or kinks. The conduit should be supported at regular intervals to prevent sagging or damage. The NEC specifies the maximum spacing between conduit supports, which varies depending on the size and type of conduit. In general, conduit should be supported every 3 to 5 feet depending on the size and material. When routing liquid-tight conduit, it is important to avoid areas where it could be subject to physical damage, such as from vehicle traffic or falling objects. If the conduit must be installed in a vulnerable location, it should be protected with a physical barrier, such as a concrete curb or steel bollard. It is also important to avoid routing liquid-tight conduit near sources of heat or chemicals that could damage the conduit or conductors. Liquid-tight conduit is typically rated for use in temperatures ranging from -20 degrees Celsius to +80 degrees Celsius. Exceeding these temperature limits could cause the conduit to become brittle or deformed, which could compromise its integrity. Similarly, exposure to certain chemicals, such as solvents or acids, could cause the conduit to degrade or corrode. When installing liquid-tight conduit outdoors, it is important to consider the effects of sunlight and weather. Sunlight can cause the conduit to fade or become brittle over time. Weather, such as rain, snow, and ice, can cause the conduit to corrode or crack. To protect liquid-tight conduit from the elements, it can be coated with a UV-resistant paint or sealant. It is also important to ensure that the conduit fittings are properly sealed to prevent moisture from entering the system. When working with liquid-tight conduit, it is important to follow all safety precautions. Wear appropriate personal protective equipment, such as gloves and eye protection. Use caution when cutting or bending the conduit, as sharp edges or burrs can cause injury. When installing the conduit, be sure to properly support it to prevent it from falling or causing damage. It is also important to avoid contact with energized electrical circuits. Before working on any electrical equipment, be sure to disconnect the power supply and verify that the circuit is energized using a voltage tester. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. They have the training and experience to safely and properly install liquid-tight conduit and other electrical equipment. Ultimately, the determination of whether sleeving the AC 240-volt NM cable through 2 feet of liquid-tight conduit before the AC disconnect is acceptable rests on the local inspector's interpretation and enforcement of the NEC and any local amendments. Therefore, it's always best to consult with the local authority having jurisdiction before proceeding with the installation to ensure compliance with all applicable codes and regulations. This proactive approach can prevent costly rework and ensure the safety and integrity of the electrical system. Remember to always prioritize safety when working with electrical systems. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector.